Good day, everyone. We're here again to take a look at simultaneous equations. And at the end of this lesson, you are expected to be able to solve simultaneous equation using elimination method, and using substitution method, using graphical method, and solving simultaneous equation involving one linear and one quadratic. And also, lastly, we'll be checking out what problems that leads to simultaneous equation. So basically, we'll be exploring mode of interpretation in that regard. And we should be able to explore one or two questions on special cases. I mean, questions that don't exactly directly look like a simultaneous equation. Of course, we see how we are to go about such. Simultaneous equations is a system in which you have two unknowns or more. Yes, you can have two unknowns, you can have three unknowns, you can have four unknowns. So in any case, when you have more than one unknown, when you have more than one variable, you can refer to such a case as simultaneous equations. By the word simultaneous, we mean that we are involving all the equations available provided. Okay, so meaning that as you're solving in one equation, you're also solving in another equation. That's why all of them are active through your solving. Okay, so now when you have a simultaneous equation in two unknown, of course you're expecting by that you have at least two equations. If it is three unknown, you need at least three equations. If it is four unknown, you need at least four equations. If you have less than that, you won't be able to solve for the unknowns, except there are other contexts that is provided. Okay, if there is no other context, such a question might have an issue. So those are the requirements when you're solving a simultaneous equation. Also, looking at the method of solving simultaneous equation, we have a lot of those methods, but for the purpose of this lesson, we'll be checking out three of them. The first one is elimination method, we have substitution method, and we have graphical methods. Okay, so all these methods are what we'll be exploring. We'll be solving questions on them. Of course, if there's any area that's not clear to you, you can just do well to listen and watch the video again. I believe it will make sense eventually. Okay, right. So elimination method. We have a question here. We have to solve the pair of simultaneous linear equation using elimination method. Okay, so we're going to be starting with the first question. We'll be starting with the first question, which is x plus y equals to 5 and x minus y equals to minus 1. Okay, for the first question, we can tag x plus y equals to 5 equation 1. Okay, if we call it equation 1, that means the second equation will be equation 2. Now, this tagging of equation is very, very important because it's when you have it properly tagged, that's when you can easily reference them. So what we mean by referencing them is maybe we need to refer to it, use it. So we need to make it known that this is the equation that we are referring to there. Okay, so it's for ease of reference. That's why we have those equation tag, and that's why we use it a lot in mathematics. Okay, so now if you're using elimination method, by elimination method, you see it's from the word we have eliminate. Yes, eliminate. So now by elimination or by eliminate, we mean we are removing one to find the other. Okay, for instance, we have xy here. Now we decide the one we want to remove. For this case, we have is a case of already having similar coefficients. Okay, so now for the coefficient of x here is 1, here x here is 1, y here is plus 1, y here is minus 1. Now, depending on the one we are deciding to eliminate, for instance, if I say I want to eliminate y here, now that's where the issue of once the coefficient that we are trying to eliminate, once the variable that we are trying to eliminate is already having different sign but the same numerical value, okay? What I mean by that is there's 1 there as the coefficient, this is like 1, this is also 1, so that's plus 1 and minus 1. Are we together? Okay, so now if you have plus 1 and minus 1 there as written there, you can easily say, okay, because they are of different sign. Okay, let me just write it this way. Different sign. When you have different sign, you do what? You add. That's what you do when there are different signs for the one that we want to eliminate. So because in this case, we are deciding to eliminate y, okay? And because they're having different sign, what you do is you add the two equations. You are not just adding the y, you are not adding just this, you are adding the two equations, okay? So that being said, okay, if we are adding the two equations as we've just stated, then let's do it. Okay, before I also move on, they have the same sign. If they have the same sign, okay, if they have the same sign, of course, what we do is we subtract, which we otherwise call we minus. When there is same sign, we do what? We minus, or we say we subtract. Okay. All right. So let's move on with the question we are trying to solve. And since it is to eliminate y, we had equation 1 and equation 2, just like we have explained. Okay. So now, if you have, of course, this equation 1 and you have equation 2 here. So what we are simply doing is we are adding them. So if you are adding them, what you just simply do is do the addition. Okay, if you are doing the addition, that means we have this, and from there, by the addition, this plus this, we know it will give us 4. That's if you're adding it together, and this will give us 0 plus 1y minus 1y will give us 0, and this x plus x will give us 2x. So that's why we have 2x equals to 4. And we can proceed by dividing both sides by 2. We divide both sides by 2, we have our x to be equals to 2, okay? So after getting the 2, getting our x value to be 2, then we can then slot in the value of x into equation 1 or 2. You can choose any of the equation to use, but in this case, we choose equation 1. If you choose 2, you will be correct in this case for elimination, because what you got here, you got it from combining the two equations. So it means the value should be able to enter any of them. Okay, so now from what we have there, we have our equation 1 to be x plus y equals to 5. If you put x equals to 2 into this, so that means you have a 2 plus y equals to 5, which you can then invariably say y equals to 5 minus 2, okay? Y equals to 3. That's our final answer. That means our x is equals to 2 and our y equals to All right, let's take a look at the second question. We have x plus 2y to be equal to 5. That's the first equation. And we have x plus 3y to be equal to 8. That's equation 2. Okay, to eliminate x, we subtract. Like we have earlier said, that for us to subtract, it means we take a look at the value that we are eliminating, which is x in this case, and the value here, minus 1 and 1, they are both having the same sign. So we said same sign will mean what? That's we subtract. Okay, we subtract. Very important. Same sign, we subtract. If we are going to subtract, of course, you can do it whichever way is more appealing to you. You can do equation 2 minus equation 1, or you can do equation 1 minus equation 2. And in this case, we are doing equation 1 minus equation 2 because we are to subtract equation 2 from equation 1. Of course, which by that, we write equation 1 first and equation 2 next. If we do the subtraction, of course, that minus will cut across everything. The minus will cut across everything. So this place will become minus. This place minus times plus will become minus 2. Okay? And this place 2 minus times plus will become minus. So, and that will give us the next value, because 5 minus 8 will give us minus 3, and 2y minus 3y will give us minus y. Of course, invariably, if we multiply through by minus 1, we have our y to be equal to 3. So after getting the first value, which is our y, we substitute y equal to 3 into equation. Like I said, you can use any equation. I decided to pick equation 1. Okay, so that means you have our x to be equal to 2 in place of y here. That's why we have the 3 here. That's what we have put in this place. Okay, so from what you have there, you can easily say that x plus 6 will be equals to 5, and x equals to 5 minus 6, which is going to be minus 1. So we have our two answers. X is equals to minus 1 and y is equals to 3. X equals to minus 1, y equals to 3. Okay, so now let's take a look at the third question, because we have 3m plus 2n equals to 7, and we have 4m plus 3n equals to 10. If you have it that way, you can say to eliminate m. Now, if you look at these ones now, their coefficients are not the same. So now, the first thing you do is to achieve equality of the coefficients. Yes, that's equality of the coefficient to be eliminated. For instance, we are choosing m here. So that means we look for a way to make this equal. And you know the rule in mathematics is whatever you do, in any case, you must always maintain balance, meaning that you must not have tampered with the whole value of the equation, as it were. So from what we have here, we can conveniently say, if we're going to make these coefficients the same, that means we are going to flip their coefficients. How do we do the flipping? The coefficient of m here is 4, and the coefficient of m here is 3. So then you multiply this one by the 4 that is here, and then you multiply this one by the 3 that is here. Okay, are we together? All right, good. So 4, this from here is the 4, because we want to eliminate m. Okay, so 4, everything multiplied by 4, and everything here multiplied by 3. Okay, which is what we're going to do. Equation 1 multiplied by 4. Of course, if it's multiplied by 4, you know, 4 times this will give us 12m, and 4 times 2n will give us 8m. Why you get the equivalence of 4 times 7 to be 28. Okay, so now we do the same thing for the other one. Don't forget, we said this times 4 and this times 3, which is what we are doing here. So equation 2 times 3, what is it going to give us? That means we have a 12m plus 9n equals to 30. Now, these two values have given birth to another set of equation. Yes, this the multiplier has helped us given birth to another set of equations. So we can target equation 3 and equation 4. Don't forget the reason why we are doing this is so that we can be able to easily refer to that equation. Okay, so now that being said, we can then conveniently say, since these coefficients are the same now, are we going to add or we're going to subtract? So what do? Then we can say we subtract equation 3 from equation 4. Okay, like I said, you can decide to subtract equation 4 from equation 3 or equation 3 from equation 4. But whichever way you are doing it, make sure you state it as appropriate. You will still get the same answer. I am subtracting equation 3 from equation 4, meaning that equation 4 comes first and equation 3 comes next to it. Just like saying I'm subtracting 2 from 5. If you are to subtract 2 from 5, that means 5 comes first minus 2. That's what I'm trying to state there. Okay, so from what we have there, we can state our equation 4, then we state equation 3. Okay, so from there, the next thing is to subtract. And if we're subtracting, of course, the minus cut across everything. Minus times plus minus, that's 12m minus 12m, that's 0. That means we have 0 there. That's a minus times plus here. It becomes minus. That's 9n minus 8n. We give us n. And a minus times plus here too. So that's minus. So that means 30 minus 28 will give us a n equals to 2. Okay, so that's the value of n. So then we can then substitute n equal to 2 into either equation 1 or 2. If you like, you can use equation 3 or 4, or just use 1 or 2. Okay, and if you do that, because those are the basic equation, or we choose 1, in this case, I choose 1. Okay, so that means we have 3m plus, in place of n, you have 2 there. That means 3m plus 4 equals to 7, and we can solve further. 3m equals to 3, and dividing both sides by 3, our m equals to 1. So we have n equals to 2 and m equals to 1 as our answer.